Welcome to Unit 4, Day 2 notes. Go ahead, pause the video and solve for X and Y on this problem. When you think you've got it, unpause and see how you did. So I'm going to start off by highlighting this triangle. The reason I'm highlighting this triangle is because I know that this is going to be an equilateral triangle because it is equiangular. So my segment addition postulate tells me this x plus this x equals 10. So that means 2x equals 10. So it means x equals 5. Okay, so if this is 5, I need to figure out what the rest of this is going to be. Well, I can use vertical angles to figure out that this is going to be 100. All right, if this is 100 and this is 40 degrees down here, together that makes 140. I need 180 degrees in a triangle, so that remaining little piece y would be 40 degrees, because y plus 100 plus 40 has to equal 180 degrees in this triangle. That was a terrible job of tracing. In this triangle right here is what the one I'm looking at. All right, so today we're going to be talking about mid-segments. So we're going to start off with the definition of what exactly a mid-segment is. I think the easiest way to do this is break it into two pieces, mid and segment. It is a segment that connects two midpoints in a triangle. And when I say two midpoints, it's on the sides. Okay, this is not a midpoint right there. Midpoints have to be on the sides. So like, that's a midpoint, that's a midpoint, that would be a mid-segment. I could say segment DE is a mid-segment. I would not be able to say right now, at least, that this is a mid-segment if I said this is F. I could not say that segment EF is a mid-segment because I do not know if F is a midpoint. I wouldn't be able to say that until I'm somehow able to get these marks, whether they're given to me or using other ways I can prove that that is true. So that means that segment DF would also be a mid-segment. So if you are a video game person, if you like Legend of Zelda, this probably looks familiar to you as the Triforce. Okay, Triforce is made up with the mid-segments, all three mid-segments of a triangle. So we're going to start with the mid-segment theorem. This is probably one of my favorite theorems. I think this one's pretty cool. It says a mid-segment of a triangle is parallel to and half the length of the opposite side. So what that means in this case is that segment DE is parallel to segment BC, and the length of segment DE is equal to 1/2 the length of segment BC. Or another way you could write that is twice the length of the mid-segment equals that other piece. Okay, these two are the same. Now, one thing I want to point out that every year students struggle with, I'm not entirely sure why, you need to pay attention to the picture. I know pictures aren't drawn to scale, but segment DE is 100% smaller than segment BC. So please do not take DE times 1/2 to equal BC. I do not know why, but students do that every year and it drives me crazy. Okay, the big thing times 1/2 equals the small thing, or the small thing times 2 equals the big thing. All right, so we're going to do a couple examples real quick. We're told that U, V, and W are all midpoints, so that means that's congruent, and that's congruent. We're told that ST is 90, and we're told that VW is 57. Notice that when I did ST, I did a little bracket here. Don't just put 90 next to it, because then it's unclear if you're meaning SW or WT or ST. Okay, so I've got to do a little bit of work to find RS and UV. It doesn't really matter which one you start with, but I know that these are mid-segments. So the one that this thing is parallel to is right down here. So I'm going to start with the mid-segment is equal to 1/2 of the side that is opposite. So the one half of the one that it does not touch. So I already know what ST is. So I can plug that in. Got to make sure I have my labels. So the length of UV is 45 inches. Make sure that you do not put that segment bar above UV because we are saying the length of segment UV. That's what this notation says. Now if I want to find VW, that has to do with this one. You could set it up as VW equals 1/2 of RS and plug in what you know, or you could set 2 times VW equals RS. Okay, they're the same thing, and either way you're going to end up having to do 2 times 57 is equal to RS to get 114 inches as the length of segment RS. All right, now this is something that is a little bit more advanced than what we've done in the past. We're going to be using variable coordinates. It says place a rectangle on the coordinate plane to find the side lengths. If I just said here is a rectangle, figure out information about it, you could put it anywhere on this coordinate plane. You could draw it at a weird angle like this. Don't. Okay, this is a bad choice. The best choice is going to be put a value here, 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 and then somewhere up here. The reason why this is going to be your best choice is because you're going to know information about 3 of these 4 points. I know that this point right down here is the point 0, 0. Okay, it's the origin. I know this point to the right. I went right some number x, and then I went up 0. Now, I need to put a variable there. That's what we mean by variable coordinates. It's tempting to use x and y, but we are going to avoid using x and y just so we don't get them confused in a case where we have to find information about a line or just in general with our formulas. We want to avoid using x and y since x and y have other terms or other definitions in these contexts. So pick a different letter. It can be any letter you want to. I'm going to pick T. This one up here, I went right 0, and then I went up a specific amount. For the same reason why I'm avoiding using x, I'm going to avoid using y. I'm going to pick M for that one. You can use any letter that you want to. Now this point here is just the combination of those last 2 that we did. We went T to the right, and we went M up. Now I can use this to figure out exactly how long everything is. Because I picked coordinates where I had them on the origin and on the x and y axis, I don't have to use my distance formula. I can know that this is a distance of t, that's a distance of t, that's a distance of m, and that's a distance of m. Okay, if I want to use my distance formula, I definitely can, but since I picked values where I get a lot of zeros, it makes my life way easier. If I had picked this crazy monstrosity, I would have a whole bunch of different variables, and I wouldn't know how to combine any of them, and it'd be a lot of extra work. Okay, so that's what it means by placing a rectangle on the coordinate plane to find side lengths. You put it wherever you want, whatever makes your life easiest, and then you use variables to represent the sides. The same can be said about a triangle. Place a triangle on the coordinate plane. The easiest triangle would be a right triangle, because then I would do the same thing I just did, where I go here, 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 and here. That was a terrible job tracing. All right, this would be the absolute best. If you've already drawn this, go ahead and erase it, because I'm going to make us do something a little bit different. The reason why I'm going to make us do something different is because this only works if it is a right triangle. It says a triangle, not a right triangle. So I do not know if the triangle that I'm supposed to be working with is a right triangle or not. So I cannot use all of these points. Okay, I can use 2 of the 3. I picked the ones on the x. You could pick 2 on the y. Doesn't really matter. It's kind of up to you. But you're going to want to have a triangle that looks like this. All right. Now, if it was a right triangle, it's possible that you just kind of like scooch that over to the y-axis, or the right angle is over here, and this is your hypotenuse. But we don't know that for sure. But I do want to use the origin, because then I get 0, 0. And then I want to use one more point on an axis. Now you can use any variable. I'm going to use the same letters we just did with M and T, but I need to be careful, and I'm going to choose something a little bit using some kind of cheater knowledge. I'm going to use 2T instead of just T. The reason I'm going to use 2T we'll see in just a little bit. This point here has nothing to do with the letter T. I don't know anything else about it, but I'm going to use the letters K and F. I'm going to use 2K and 2F. If you used 1K, 1F, and 1T, that's totally fine. It's a variable. You got to choose it. The reason why I chose 2 times is going to be in the next thing on the next slide, and we'll see more so why that works. So now it says find the side lengths. One of these side lengths is really easy. This side length is 2 times T. Now if I want to find this side length, I need to use my distance formula. So my distance formula, if I name these points A, B, and C, segment AB is going to be the square root of 2K squared plus 2F squared. So that's 4K plus 4F, K squared and F squared, excuse me. That's the square root of 4 times K squared plus F squared. And you can break that down even further to get the length of AB is 2 times the square root of K squared plus F squared. I went through that really fast. All I'm doing is the distance formula and simplifying. Okay, I squared the things. I factored a 4. Okay, when you multiply, this is another version of kind of using that factor tree. But that would be what this length is. 2 times the square root of K squared plus F squared. Now if I want to find BC, that's going to be a little bit more work. I'm going to do this one very quickly as well. It's not that big of a deal if you're like, what just happened? How did he do that so fast? So our distance formula is a difference in x's. So 2k minus 2t squared plus the difference in our y's squared, which is just 2f squared. You would FOIL this. So if I'm going to FOIL this, I know I'm going to get 4k squared minus 8kt and then plus 4t squared plus 4f squared. I FOILed in my head instead of writing it down. That's how I got this long thing. That's as simplified as I can pretty much get. I can go one step further, I guess, and do 4 times k squared minus 2kt plus t squared plus f squared, and then get 2 times the square root of all this business. But this looks absolutely hideous. Very rarely are you going to need to ever put something on a graph where you know nothing, where you know none of these measurements. Usually if you're using variable coordinates, I will tell you, hey, the length of one of these sides is this, or something along those lines, or you could say, okay, well, if this length is this, I know what my variable should represent in order to get that distance. But this is just what putting it on the coordinate plane means. We can do all of the math that we've ever done with distance formula and midpoints and all that fun stuff with variables. It's totally allowed. And that's where this is going to come in handy. And this is why I use those 2 times values. I'm going to put this triangle on the coordinate plane. Okay, this is a coordinate proof. This is different than what we've done before. All right, normally we do our 2-column proofs. I'm not going to write out a 2-column proof. I'm going to have this at the origin. This is 0, 0. This is going to be 2t, 0. And this was 2k, 2f. The reason why I picked those is because I'm going to be finding the midpoint. Remember, our midpoint xy is going to be x plus x over 2, excuse me, and y plus y over 2. That divide by 2 is the reason why I had these 2 values here. Because by doing so, I'm able to figure out what D and E are. So halfway between 0 and 2k is k. Halfway between 0 and 2f is f. So D is of the point kf. All right, because that's a midpoint. Okay, it's given to us that it's a midpoint, so we are able to use this. Similarly, halfway between 2k and 2t, I would have to do 2k plus 2t over 2, and then 2f plus 0 over 2 to get this point. Those 2's all cancel out, so this would be k plus t, comma, f. So those would be my coordinate points. Once I've gotten to that, now I can use all of my theorems about midsegments to prove these two things. So I'm going to do this one in red and this one in green. The one in red is actually probably the easiest. So I chose these points very precisely, very particularly. I could have put this anywhere I wanted to in on the graph, but I picked values so I have these zeros, which makes my life easier. So I'm going to start by finding the slope of segment DE, because in order to prove that something's parallel, they need to have the exact same slope. So the slope of segment DE is going to be f minus f over k plus t minus k, which is 0 over t, which is 0. So all I did was y2 minus y1 over x2 minus x1. This f minus that f over k plus t minus k. All right, now I'm going to do the same thing with segment OC, but this one's going to be like really easy because it's 0 minus 0 over 2t minus 0, which is 0. So since segment DE and segment OC have the same slope, we are able to say that segment DE is parallel to segment OC. All right? That's the beginning of a coordinate proof. That's the first part. We've already done half the work. Okay? The next part has a little bit more work involved. Okay? Most of it's not going to be that bad. I want to show this, so I need to calculate this and calculate that. So to calculate DE, I need to find the length of that. So the length is going to be the distance of k plus t minus k squared plus f minus f squared. This just becomes a square root of t squared, which is t. All right? The k's canceled out, and f's canceled each other out. So the length of DE is just t, whatever t is. Because of how we picked this, you could have just counted over. Okay, now it's hard to count because I don't have any like lines, but the difference in your x values is just t. It's easier than if it had been like 5, 2, and 12, 2, because it literally just says, hey, plus t. That's how far I moved. That only works because we picked these specifically, and we have the y values being the exact same. Now, if I want to find OC, well, OC, for the same reason, I can just say I counted over 2t. I went from 0, 0 to 2t, 0. So DE is equal to t, and OC is equal to 2t. We've already shown that, but we have not shown what we're trying to show. Half of OC is half of 2t, which is just t, which is DE. Okay, so you could say we are done at that point. I didn't even have to write a sentence because it just said show or prove that DE is equal to half of OC. Here's our work showing that half of OC is the same thing as DE. This is a hard problem. This is definitely one of the most challenging problems, if not the most challenging problem I'm going to give you this year. All right? If you are able to follow along like 80% of the way, that's fantastic. You're a rock star. Okay, some of this stuff is very, very challenging and very complicated. If you look at it and try it a few times, it won't be that bad. Okay, when I say that, I mean the problems that you're going to be actually working on are not going to be nearly as complicated as this, because we just proved a theorem. Okay, some of the theorems that we prove are very, very, very complicated, and this is a pretty complicated theorem. So you're not going to have to be able to prove this specific thing on a test by yourself. That would be mean. All right, so make sure you do the day 2 homework, and I hope you have a great day.